Hello and welcome to 4.2. This focus is on reactions. We're going to continue on from 4.1, which looked at balancing equations, chemical equations. Now we're going to look at three specific types of reactions, starting with precipitation reactions. Just going to give you a brief overview, kind of summarize what the book tells you. Should be about a 10 to 15 minute video. All right, so what is a precipitation reaction? It is a reaction when a solid is formed from two aqueous ionic solutions. So there's a lot of words in there. So let's kind of unfold what that means. So here's an example of a precipitation reaction. Look on the left-hand side. So on the left-hand side, I'll make this a little bigger. What we have is silver nitrate and calcium chloride. Now what makes these aqueous is this AQ here. So you have two substances that's AQ. Ionic means you have a metal or a cation with an anion. Okay, so you have a positive and a negative charge together to form a neutral compound. So I have two neutral compounds with in this case, metal and a non-metal. This is a cation and an anion. Just means a positive species and a negative species. They react, and notice what they do. They undergo what's called a double displacement reaction. So a double displacement reaction occurs. And it's really quite simple what happens between these two compounds. I identify what my cation is in both, or my metal, and they just switch places with each other. So notice if silver switches places with calcium, what you end up with would be silver chloride, balanced of course on this side. And if calcium went to where silver was, then you would have calcium nitrate, which is what we have over here. The only thing I am missing is a state of matter for calcium nitrate. Okay, so how do you identify this? You identify it by seeing that there are two aqueous species that are both ionic. The metals just switched places with each other, and one of your products is a solid. So I won't have you predict products or fill in what the products are. I may have you balance the reaction, so you might have to determine what the coefficients are. But really you have to be able to look at this type of reaction and name it as a precipitation because a solid was formed. So what does this look like? Let me give you a little example down here. I'm going to pull this up. So notice this beaker. You can see there is a solid within a liquid. So this happens actually in water. That's why it's an aqueous solution. And what happened here is two aqueous ionic solutions were dissolved, or rather transferred into this beaker, and a precipitate, which is this kind of yellow golden solid that falls to the bottom, is formed. So this is an example of a precipitation reaction. So how do you determine if a reaction will form a precipitate? I'm not going to have you use this, but what you would use if I had you predict it is called a solubility chart. So a solubility chart tells you whether or not certain species will be soluble or insoluble. So you'll need to know these terms. Soluble just means that it will dissolve. So no solid will be present. And insoluble means it will not dissolve. So this is when a solid will form. Awesome. Let's go on to our next type of reaction. All right, for our second type of reactions, we're focusing on acid-base reactions. As I wrote in the previous slide, acid-base reactions are also a type of double displacement reaction. And we'll see that when we look at a specific example below. Okay, so what happens overall in an acid-base reaction? Well, as you could probably determine or predict, an acid reacts with a base and forms water in an ionic compound, also referred to as a salt. It's a neutral ionic compound. It's a salt. So here is a specific example at the bottom. Let's identify what each species is. So right here we have our acid. Now, why is it an acid? It's an acid because it has a hydrogen in front that falls off or is donated or given off into the solution. So an acid contains a hydrogen, say one or more, at the beginning of the chemical formula. So that's how you will be able to identify them in this class. If you see a chemical formula with hydrogen in front, you can likely assume that it is an acid. All right, next we identify our base. So in this class, bases will contain this OH anion, which is referred to as hydroxide. So acids have that H in front. Bases have OH minus or hydroxide. So we'll make this as simple as we can. They contain, or bases contain, a base contains an OH. All right, so we have our acid and our base. Now, how is this double displacement? Well, let's look at our cation again. That's in front. And let's switch places between the two of them. So notice what happens when Na switches places with our hydrogen. We end up with NaCl, so that's our salt or ionic compound. And then if hydrogen comes over here, we would have HOH. We would have HOH. Now notice that's the same thing as H2O. Okay, the plus right here, just so you know, is not a charge. It's the two products on the right-hand side. So our HOH becomes H2O, and we have an acid and a base. So you'll also have to identify these types of equations by noticing that one species has that acidic hydrogen in front of its chemical formula, and the base has an OH next to a metal. In this case, our metal is sodium or Na. Okay, on to our last type of reaction for Chapter 4, and that is an oxidation reduction reaction, also known as redox for short, a redox reaction. This occurs when electrons are transferred in a chemical reaction. So two things I want you to note here, just to remind yourself, is number one, this is a reminder that electrons are negative. Negatively charged. And actually the second is a reminder from the reading, but it's kind of a new concept, that the way we determine electron transfer is by noticing or indicating what the oxidation number is on the species. So oxidation numbers show where electrons, I'm abbreviating right here, are, or I should say have been transferred. That'd probably be a better way to say it. Electrons have transferred. All right, so on a quiz or on an exam, I would give you the oxidation number in a reaction for each atom involved, and you would have to determine where the electrons were lost and where they were gained. That will also tell you what species was oxidized. Notice in the name oxidation, that means one species is oxidized and one species is reduced. So before I start assigning oxidation numbers, I'm going to give you a little mnemonic to live by when it comes to oxidation reduction reactions. Here is the mnemonic, or I should say oil rig, not mnemonic. OIL, oil, rig, RIG. So let's fill in what this acronym stands for. O stands for oxidation. I stands for is. L is loss of electrons. R stands for reduction. I stands for is, and G stands for gain of electrons. All right, so what I'm going to do is I'm going to look at this example equation, which is balanced. Zinc reacts with hydrochloric acid to produce hydrogen gas and zinc chloride. I'm going to assign an oxidation number, which is, you can think of it as a conventional charge. We use it to assign where electrons are on top of each atom in the balanced equation. I'll use green. So above zinc, zinc has an oxidation number in this state of 0. The hydrogen has a +1. Chlorine has a -1. On the right-hand side, this hydrogen has a 0. Zinc has a +2. And chlorine has a -1. So let's use these oxidation numbers, which again will always be given to you on a quiz or exam, and use them to determine what species lost electrons and which gained. So let's highlight something. Let's highlight zinc. So zinc on the left-hand side has an oxidation number of 0. On the right-hand side, it has an oxidation number of 2+, or +2. So you have to ask yourself, were electrons lost or were they gained? Now zinc became more positive. Write it down here. Zinc became more positive. So that means it lost electrons because electrons are negatively charged. So let's look at our two acronyms. Oxidation is loss of electrons. That means zinc was oxidized. So it was oxidized. In an oxidation reduction reaction, there is always a species that is oxidized and a species that is reduced. So let's identify which one was reduced. So I'm going to highlight another piece for us. Let's look at chlorine really quick. Notice chlorine has an oxidation number of -1 on the left and -1 on the right. That means it was not changed. Okay, there was no net transfer of electrons that chlorine was involved in, or chloride was involved in. So let's now go to hydrogen. Notice hydrogen on the left was a +1. Hydrogen on the right was a 0. It became more negative, therefore it gained electrons. Reduction is gain of electrons. So we can say that hydrogen was reduced. So that is what you'll have to be able to identify in an oxidation reduction reaction, is the species that was oxidized and the species that was reduced using this acronym called oil rig. And this essentially answers the question below that states, how do you determine if this occurred? So how do I determine if there was a redox reaction? You determine this by comparing oxidation numbers on the left to the right, or on the reactants to the products for each type of atom. If there is any change in the oxidation numbers for a type of atom from the left to the right, you can determine a redox reaction occurred. And that is it for this video. Let me know if you have any questions.